Welcome to Ars Electronica and to Ars Electronica Home Delivery with this week's topic all about the brain. So today is going to be the first day and a quick introduction into the human brain, how it's like the anatomy of it, the basics of course, and a quick history on this topic. And we are already standing in front of the first exhibit I want to show you today. So this is our preserved brain specimen. It's from an 82-year-old man, and who's obviously dead already, but that was his brain. And if we take a closer look right now, maybe from the front, so first of all, in which direction would this person be looking? Up here we have the front and the back. And what we can already see here are different regions of the brain. So the biggest part up here, it's the cerebrum and the cerebral cortex. Down here we have a part that has a slightly different texture. That's the cerebellum. And if we peek a little bit inside, we can see parts of the brain stem. Those are three major parts of the brain. And what do those parts do? So the cerebrum, or the cerebral cortex, which you can see a little bit better here. So we have another brain to show you. We can pull it apart. So that's the cerebrum, and the top layer would be the cerebral cortex. That's the biggest part of our brain, so it's about 80% of our whole brain is the cerebral cortex and the cerebrum. And in here we have the highest developed things we can do with our brain, like planning ahead, planning into the future, or thinking about stuff. And also our senses are located in the cerebral cortex. So in the back part, we see, so to say, and on the right and the left, the senses of hearing are used, so to say. And if we look inside, that's the brainstem, this part here, the part that was barely visible on our real brain specimen. And this part is, in an evolutionary sense, the oldest part of the brain. So in there, things like our heart rate or our breathing, our digestion are processed. So without this part, we wouldn't be able to live, because all those things that are processed in there, we don't do on purpose, but we need to do them to be alive and to stay alive. And the last part here, the cerebellum down here, is responsible for sensoric and motor skills. And funny enough, because of the cerebellum, we are not able to tickle ourselves, because it's also responsible for the sensoric consequences of our own behavior. So because of that one, just other people can tickle us and we can't do it ourselves. Question is, how do we know all that? Because people didn't just come up with what our brains can do and which parts of our brains are responsible for which actions. So if we look back in time, in ancient Rome is the first part of the history I want to tell you today. And in ancient Rome, a man lived. His name was Claudius Gallienus, and he was one of the first men who thought about the possibility that not the heart is the center of our whole being and of our consciousness, but the brain. And how did he come up with that? So he was a doctor for gladiators, and he also did vivisections on animals. So he was able to look at gladiators and their injuries and stuff and determine, okay, that's happening all the time, and because of this injury, this deficit is coming up. Why is it happening that when people fall on their heads, they are not conscious anymore, for instance? And the vivisections, so vivisections on animals, of course, mainly on goats and on monkeys. He tried to injure the brain of living goats and monkeys and tried to figure out if he cuts this part of the brain, what's the consequence of that, and so on and so on. So he was one of the first people who thought that the brain might be the center of our consciousness and of our being, and not the heart. For the next person, the next person I want to introduce you to, we're gonna switch locations and we're gonna walk over here. And here we're gonna take a look at a young man. His name is Phineas Gage, and he lived in 1848. So we jumped quite a lot of time from the ancient Rome to 1848. And Phineas Gage was a worker at the trails. So he helped build the trails in the US, and he had an accident. So as you already can see here on the picture of his skull, what happened is that because of an explosion, an iron rod went through his left side of the skull, through the eye, or underneath the eye, and up through the top of the skull. And this iron rod went straight through, and he survived. And if somebody has such a big injury, it's quite a big thing that he was able to survive. And after a few months, all his injuries were healed, and he was fine again on the outside. On the inside, people reported that Phineas Gage was a very sociable, very likable person. And after his accident, that changed a little bit. So after the accident, people reported, his friends and his co-workers reported that his character changed completely. So he wasn't as nice to work with anymore. Social interactions were not that easy for him, and also he was kind of aggressive, or he got kind of aggressive because of this injury. And of course, people didn't know why. How would they? People didn't know which parts of the brain are responsible for which actions we take. So you can see, and his injuries were taken, and through new technology in the year 2012, this whole accident was redone, so to say, and through new technology, we were able to look at the brain of Phineas Gage again and which parts were injured. And because of that, we know that the frontal lobe, so here, that part was injured, and that part is responsible for planning and planning ahead into the future and strategies and suppressing like emotions and stuff. So that's one of the reasons why he couldn't do that anymore. That's Phineas Gage. So one single person that changed how we look at brains, and one person that helped scientists a lot to figure out how our brain works. And that's also the thing, like neurobiology and how we research the brains, we as humans. We can just, or we mostly look at people who are sick. That's even the same today. So people with epilepsy, for instance, oftentimes get their brain scanned and have electrode implants in their brains. So because of that, we get a closer look how their brains work. But like a normal person, who is normal anymore, but a person who isn't sick or doesn't have an illness isn't looked at that closely in when it comes to the brain. So because of Phineas Gage, we know that to control our emotions and to plan ahead, we need our frontal lobe. And two other examples would be Wernicke and Broca's. So those two, separate from each other, discovered something very similar. They discovered that the production of speech and language has its own area in the brain, and the comprehension of language and speech has its own area in the brain. How did they figure that out? They figured it out because they had two patients separate from each other, and one patient wasn't really able to understand what was going on in his surroundings, but he was able to speak. He was able to speak grammatically correctly and everything that, but his sentences didn't make much sense. And the other one was able to understand everything, but he wasn't able to talk. And after they died, Broca's and Wernicke looked at their brains and compared them to brains of people who didn't have any disabilities or anything. So they figured out something could be wrong in the brain, and they put those two brains side by side and figured out that some areas in the sick person's brain were underdeveloped and smaller in comparison to the normal brain. And that's how they figured out, okay, this must be the area for speech comprehension or for speech production. So that was the first small input and introduction into our human brain. I hope you enjoyed it, and have a nice day.